Question 2 is all about your knowledge of alcohols and the reactions of alcohols. So we'll start off with something potentially looking quite confusing. We've got 6 alcohols here. So the first thing I would be doing is just looking at, well, there's 6 carbons in that one, there's 7 in that one, there's 5 in that one. I've worked out the H's as well, you'll see why in a second. 3 carbons in that one, 5 in that one, and 5 in that one. So which 2 alcohols, this is AI, are structural isomers of one another? So they've got to have the same molecular formula, different structural formula. So we're looking at the 5s here, aren't we? So it's either this one, or this one, because these have all got different carbons in them. So that's why I've gone and worked out the H's. So this is 5 C's, 12 H's. So is that one. This has only got 10 H's because of the double bond. So they must be your structural isomers because we've got the same number of carbons, hydrogens, and oxygen. Which alcohol is a tertiary alcohol? So what's a tertiary alcohol? It's got 3 carbons directly bonded to the carbon with the OH group on. So there's only one, and it's that one there, H. So there's that OH carbon with 1, 2, 3 carbons directly attached. Which alcohol can be oxidized to a carboxylic acid using acidified potassium dichromate? So only primary alcohols do that, and there's only one primary alcohol in the list of 6, and it's F, because the OH carbon is directly bonded to 1 carbon. What's the molecular formula of alcohol G? Well, we've already worked out the carbons, the hydrogens, so it's C5H10O. Just be careful there, don't try and give the structural formula there, just literally group all the carbons, all the hydrogens and the oxygen together. What's the name of alcohol C? So we've got 1, 2, 3, 4, 5. We've got a continuous chain of 5 with the OH on carbon number 1, 2, 3. So this is pentanthreol. That must be carbon number 2. So 2-methyl pentanthreol. Definition. Homologous series. So that's a series of compounds with the same functional group, but each successive member differs by a CH2. Alcohol D is reacted with 3 different reagents. So this is testing your knowledge of reactions now. So we know that alcohol D is secondary. You can see there the OH carbon is directly bonded to 2 carbons. This is secondary alcohol. Complete the flow chart. So if you heat secondary alcohols with acidified potassium dichromate, you're going to get a ketone. So you turn the OH group, the functional group, into a ketone. If you react an alcohol with a carboxylic acid in the presence of an acid catalyst, that's esterification. And so we're going to get the ethanoate part of the ethanoic acid joining with the OH group. So we get this ester. And then the final part, we're going to heat with an acid catalyst. So that's your dehydration reaction. So in dehydration reactions, you need to remove a water molecule. And to do that, you need to take off the OH and an H, but it must be, the H must come from an adjacent carbon. That's the rule. So in this one here, I've taken the OH obviously and that hydrogen there. So I'm going to get a double bond here. And in this one, we can take the OH and this hydrogen off this carbon here. And so we'll get a double bond there. And they're obviously different structures.